Most of them are sort of horizontal or sort of vertical, called erectophile or planophile. And some are heliotropic, right? Some of them, depending on where the sun is in the sky, those leaf angles change, like soybeans. Legumes in general will track, leaves will track the sun as it moves through the sky. So their leaf angle distribution changes throughout the day depending on where the sun is. That's called heliotropic. There's a nice book chapter in this book that describes this. Okay, so here's an example of maybe a near vertical leaf angle distribution. This is Equiseno, you know, that horse tip, kind of pretty vertical. Maize, as I said, is a spherical leaf angle distribution. Water lilies, mostly horizontal leaf angle distribution, although, you know, look at this one, it's not, that's got a bit of an angle to it, so it's not entirely vertical. And here here are a couple of graphs that show this extinction coefficient, G of theta or K of theta, as a function of the angle theta for different leaf angle distributions. So, you know, we can come up with it, we can deal with it. Move faster. Galen Campbell came up with a very useful function to represent many leaf angle distributions, and that is an ellipsoidal leaf angle distribution. So if you think of a spherical leaf angle distribution, that's an ellipse or an ellipsoid with the axes the same. But you can squish that down into a pancake or squish it up into like a cigar-shaped thing. And those are ellipsoids, but with different ratios of the axes of the ellipses, right? So prolates, I guess sometimes they call spheroids, right? Prolate spheroid and oblate spheroid, perfect sphere. And Galen came up with a way of representing these types of leaf angle distributions, which, you know, in the extreme case, this one gets pretty horizontal. This one can get pretty vertical, or you get right in the middle for the sphere, depending on the value of this parameter chi in this equation. So here's the ellipsoidal leaf angle distribution. It's very useful to represent, you know, to use one equation to represent any plant canopy you might think of, except maybe a heliotrope. And, you know, here's the equations. Very useful. Galen Campbell also is from the Campbell family that started Campbell Scientific, you know, for data loggers and stuff like that. Okay. Narendra Goyal was fond of using a different leaf angle distribution, a beta distribution representation of leaf orientation. Okay, so that's this function, or this function. Let's not get involved in the details. There are other ways of representing leaf angle distributions. But it's almost out of time, so I think I'll start here next. As you're going around between now and next Tuesday, if you see a plant canopy, right? Okay, so the grass is kind of brown now, but, you know, think of it as being green, or, you know, whatever you can see. You know, try to convince yourself that the way you look at that canopy, what you can see through that canopy depends on the direction you're looking at that canopy. And if we can quantify that distribution of leaves in the canopy through leaf angle distribution, That's very useful, for example, separating the total leaf area in the canopy into sunlit and shaded fractions, which is the first step that we'll need to do in scaling up from